In this question, we see a potential divider circuit with a variable resistor connected at the top with resistance ranging from 0 to 12 ohms and a fixed resistor of 8 ohm connected to an output. We are to determine the min and max values of the voltage across this 8 ohm resistor, which is the voltage of the output. So the answer to this question is C. And let's just label the two resistance as R1 and R2 and remember how to use our potential divider equation. Now, this next step is critical. The minimum voltage output occurs when R1 has a very high resistance. How do we arrive at this conclusion? When we look at this voltage output over here, this voltage output is linked to the voltage across the 8 ohm resistor. The meaning of a potential divider equation simply means that when the component has a very high resistance over here, it will grab a bigger share of the 12 volts. And that's the meaning of a PD equation. It is indicated by the fraction over here also mathematically. So if we want this output here to be very, very small, minimum, we also want the voltage here to be very small. We want the resistance here to be small also. That means that the resistance over here must be as big as possible so that the voltage across R1 is as big as possible. It will grab a very big share of these 12 volts, leaving very little voltage for R2. Hence, this output voltage is the minimum when the resistance here is the highest. Okay, so we can arrive at the other statement. The maximum voltage output occurs when the variable resistance is the smallest. With this, we can then plug the values of the variable resistor into the potential divider equation using maximum resistance of 12 ohm for R1 to get 4.8 volts as the output voltage minimum, and plug in the variable resistance of 0 ohm to get a maximum voltage output of 12 volts.